Hi there, a few questions on functions. If we're given that f of x is 4x squared add 3x minus 2, that means our input is just x, and this is the rule that we have 4 times x squared add 3x minus 2. But now we have an input here of x add 2, and we want to evaluate this and simplify it. Now this becomes, so f of x add 2 minus 20. Now our input now is not x, but it's x add 2. So we have 4 brackets x add 2. So wherever squared, wherever we have x, we're substituting the input x add 2, add 3x add 2 minus 2, and now we have to add the negative 20. So this gives us 4 into x squared add 4x add 4 add 3x add 6 minus 22. That's 4x squared add 16x add 16 add 3x minus 16, which evaluates to 4x squared add 19x. Now what about if our input is x minus 1, and to that we add 1? So f of x minus 1 and 1 is equal to 4 brackets x minus 1 squared add 3 x minus 1 minus 2 add 1. This gives us 4 into x squared minus 2x add 1 add 3x minus 3 minus 2 add 1. This evaluates to 4x squared minus 8x add 4 add 3x minus 5 add 1, and simplifies to 4x squared minus 5x. And that's it. Thanks for watching. My name is Alistair. Bye for now. Hello. Differentiate using partial fractions. This is our function. This is identical to writing in partial fractions 4 over 3 into x minus 4 minus 1 over 3 into x minus 1. Now, I've covered partial fractions in one of my previous videos. Have a look on my list of videos and you'll see it. So we have these two constants, 4 over 3 and negative 1 over 3. So we have our two partial fractions. Now we can actually apply differentiation to these two partial fractions. So we have the operator of differentiation on f of x that's equal to d dx. First 4 over 3 x minus 4 to minus 1. So we've taken x minus 4 into the numerator. Now it has an index of negative 1 minus d dx of 1 over 3 to minus 1 to the minus 1. This implies that dx of f of x is equal to minus 4 over 3 x minus 4 to minus 2. And this becomes positive because negative 1 times a third is negative a third is positive a third. X minus 1 to minus 2. And just to tidy this up, we'll take these two in brackets and put them back into the denominator so we can write them as positive. It's negative 4 over 3 into x minus 4 squared, 1 x minus 1 squared. So a useful tool for partial fractions is to be able to differentiate rational fractions of this type. Thanks for watching. I'm Alistair. Bye for now. Hi, how do we differentiate this trig function, which is a function of a function? So we can rewrite that as y is equal to sine x all squared. It's the same, but it's just conventional and standard to write it in this format. Now if we differentiate this dy dx, and we differentiate this as it is, so that's 2 sine x, and then we differentiate what's inside the brackets, which is sine x. Remember, this is an operator operating on whatever function it is. Here d dx is operating on y, which is all of it. Here now we're dealing with what's inside the brackets, a function of a function. And this now is equal to 2 sine x cosine x. Incidentally, this can be written as sine 2x. Here we have y is equal to sine 2x, add 2 cosine 2x. And we know this, that if y is equal to cosine ax, then dy dx is equal to minus a sine ax. Just a standard differential. So dy dx is d dx of sine 2x added to d dx of cos 2x times 2. And this gives us 2 cos 2x minus 2 times 2 sine 2x, which you can write as 2 cos 2x minus 4 sine 2x, which we can factorize as 2 into cos 2x minus 2 sine 2x. our dy dx here will be our operator d dx of sine 3x minus d dx operated on cos 3x. This gives us 3 cosine 3x, add 3 sine 3x. We factorize to make it cosine 3x, add sine 3x. Here we make use of if y is equal to sine ax, then dy dx is equal to a cosine ax. Thanks for watching. I'm Alistair. Bye for now. Hello mathematicians. Find the slope of the tangent to the curve x cubed add 2xy add y squared is equal to 6 at the point 3, negative 3. Here we have an implicit function, and so we'll differentiate each term to start with. So we have 3x squared add, now this is a product, so be careful with this. I'll put it in brackets, it's 2y add x dy dx add 2y dy dx is equal to 0. And now we can factorize this. We have this x and 2y multiplied by dy dx, so we can put that separately. X add 2y dy dx, and we have minus 3x squared, and we have 2y. We'll take it on to the right hand side, and this becomes minus 3x squared minus 2y. And now we have that dy dx is equal to minus 3x squared minus 2y over x add 2y. So now we can find what the gradient is at the point 3, negative 3. All we have to do is substitute for x and y. Let's make sure we keep on screen. So we have minus 3 squared, this is minus 3, add 2 times minus 3. Right, so the dy dx, when we substitute our values for x being 3 and y being negative 3, gives us the gradient of 7. So we know the gradient of the tangent at the point, at this point, which is 3, negative 3, is 7. And the slope is tan inverse of 7. So this is the slope. And this is equal to approximately 81.9 degrees. Let's call it, let's round it off to 82 degrees. Thanks for watching this video. My name is Alistair. Bye for now. Hello. Here we are asked to differentiate this implicit function 6x squared, add 8xy, add 9y squared equal to 14. Note that we have a product here, 8xy, so we have to apply the product rule as we differentiate this term. So first that will give us 12x, add 8x dy dx, and open this in brackets, add 8y. So this is the result of differentiating this, applying the product rule for differentiation. And lastly we add 18y dy dx. This is equal to 0. And from this we can rearrange, we have like terms together, we'll have dy dx, we're going to take over the minus 12x becomes minus 12x, and also the 8y becomes minus 8y, and this is divided by 8x and 18y. And that's it. A straightforward way to differentiate an implicit function. This is the result of differentiating this product, 8xy. I've covered the product rule and questions on it in previous videos on the playlist A-Level Further Maths. Thanks for watching. Bye for now.